Hello students. Today we will be talking about resistance. So resistance is a factor that opposes the motion of electrons in a circuit, which is just like friction. For example, if friction is more, then the speed of the rolling ball would be less. Just like if you roll a ball on a sand, it won't roll fast enough, but if you roll the ball on a marble floor, it will roll faster. Because the resistance is more on sand and less on marble. Similarly, when we are talking about electric circuit, friction is replaced by resistance. So resistance is a factor which opposes the motion of the electrons flowing in the circuit. Now, resistance depends upon these three following things. This is called rho, which is a resistivity, or you can say resistance per unit length. Then this L is the total length of the conductor and A is the cross-sectional area. So as you know, any quantity that is on the numerator is directly proportional to the quantity that we are measuring, which means if the quantity on the numerator increases, then the one which we are measuring also increases. For example, if you increase the length of the wire, the resistance also increases. Whereas the quantity which is in the denominator is inversely proportional to the quantity that we are measuring. For example, if the area increases, the resistance would decrease. So just imagine if you are passing through a narrow lane and there are 10 people in that lane, then you might experience a lot of collision among other 10 people in that area, isn't it? But now if the lane become broader, you can quickly run and get to the other side of the lane without any collision. Similarly, in a wire, if the cross section of the wire is smaller, then the electron has to experience a lot of collision, which increases the resistance. So area decreases, resistance increases. Whereas if you take a thicker wire, so this can be considered as a lane which is broader, so the electron would quickly travel from one end to another end without facing a lot of collision. So more the area, less will be the resistance. Now similarly, if we talk about length, say if we keep the area constant and increase the length, then an electron traveling through this wire has to experience a lot of collision with the other atoms, and therefore the resistance would increase. But if you keep the length short, then the electron may not have to experience that many collisions and can quickly pass on to the other side of the conducting wire. Okay, now to prove what I have just explained, let's do this little experiment here. So the resistance right now is 0.667 ohms. By the way, ohms is the SI unit for resistance. So as you can see, let's see how the resistance increases with the increase in length. So as per the discussion, I have told you if the length increases, resistance would also increase. Now let's see if that's true. Let's increase the length. See, as we are increasing the length, the resistance is also increasing. Now if I am decreasing the length, the resistance is also decreasing, because the electron has to experience less collision because the length is less. More length, more resistance. Less length, less resistance. Okay, now let's check the same thing with area. As per the discussion, we know as we increase the area, the resistance decreases. As we increase the area, resistance decreases. As we decrease the area, resistance increases. So I hope this would help you to understand the concept of resistance. Sometimes in numerical, instead of area, you might also get radius, because the wires are always cylindrical in shape. So if you get radius, then you have to replace area with the formula of pi r squared, okay, which is also the area of a circular cross section. So I hope that was enough for you guys to understand the concept of radius. If you want to see more videos like this, do join my WhatsApp channel and also my YouTube channel. Thank you. Have a nice day.